this particular webinar. So today I'm going to be talking about architecting drone programs. So my name is Varun Sarwal. I'm the founder and CEO at Hammer Missions. Just a quick introduction to myself. So I'm essentially a computer scientist by background. As Christina mentioned earlier, essentially I've been working in the commercial drone industry for the last 7 years. Prior to Hammer Missions, I started a fixed-wing drone manufacturer company called Marble Aerospace. So that builds fixed-wing drone aircrafts for maritime surveillance. And I've also been working closely with the Royal Academy of Engineering as an Enterprise Fellow, who really helped me get Hammer Missions off the ground. So today what I want to do is essentially I want to share some of my experiences and observations in the drone industry. I think there's quite a few things that's happened in the industry over the last few years, so I want to touch on that. But essentially, I want to talk about workflows. I want to talk about architecting drone programs, and essentially, what does it all mean in the drone industry in terms of collecting, processing, sharing that data. But before I get into that, I would love to put forward a question. So, can someone guess what this is in the slide over here? You can either shout out or you can put it in the chat, maybe if it's easier. Just going to go out of this mode and look through the chat quickly to see what people are saying. So any guesses on what this image is?
It's probably the first ever IBM computer.
Okay.
I think about an old computer as well.
It's an old computer. Okay.
Someone in the chat, Hongwei, said a supercomputer in the 70s.
Supercomputer in the 70s. Okay. Do you recall? Does anyone know what was the purpose of this computer? What was it built for?
I think about calculations, but
yeah.
okay. So Sergio mentions seems like a Unisys or IBM data center first generation.
Yeah. Okay. Great. So we're getting close. So essentially, this is an IBM 360 mainframe computer. So that, I mean, it's spot on. Like you correctly identified the computer. Obviously, it takes the size of a room, which is astonishing given where we are with computers now. But essentially, it was one of the first computers that could do more than one application at the same time. So it was one of the kind of breakthroughs at the time, 1964, I think, where you could use this for scientific computing and business applications. And obviously, it still took the size of, better part of a room to store it, which is just incredible to think about it. And that was essentially the biggest thing at that time. So if you look back, it's just incredible how some of these things have evolved. And so one of the questions you ask now is what's happened since? I mean, obviously, now we've got a form factor which is, orders of magnitude smaller, but running millions of applications as opposed to just 2 applications or 2 main applications. So it's interesting because this particular trend, it's not unique to computers. It's happened to phones. You used to have phones which you had to make sure you get the number right, otherwise you will start all over again. Or you essentially now you've got phones that you don't just use for calling, you use for so many different other use cases and so many different purposes. Same things happened in the computer game industry. You used to have an arcade where you used to go just to play one game on one machine. And now you've got a plethora of different games happening on a single machine, on a single console. And the same thing is in the works with the watch industry. And I still like wearing an analog watch, but there is a whole market for digital watches and all the things that you can do with them. So what I'm trying to get at here is that over time, it seems that we as humans, we make these specialized machines which become general purpose machines over time. We try to sort of build them in a way that over time we're using them for more than one use case. And I wanted to sort of try and understand why that happens. So from my perspective, I think hardware for any one of these specialized machines is just an entry point. It's just a way for it to provide us with a platform for us to be able to do something. And it's actually the software and the applications and the data and the actual use cases that drive the ROI on that hardware. And over time, it's essentially cheaper to do more things in the same hardware and to reuse the hardware, because essentially, as we've probably learned from coming out of a pandemic, sometimes it's cheaper to do things in the digital world than it is to do it in the physical world. So we kind of have that trend that's been going on for a long time in different industries. And it's interesting because I think I see that the same thing's happening to the drone industry. So the drone industry, unmanned robotics are very much on a similar journey. If you go back to, pre-2010, I think the only real applications that you would have for drones would be around the military side of things, where you would use them for reconnaissance applications. And those applications haven't gone away, but since 2015 onwards, we've just seen a massive rise in applications for drones. First and foremost, there's a lot of productivity in agriculture, followed by search and rescue. And moving on to today, we're seeing a lot of different applications in precision mining, construction surveys, and obviously energy. And within energy, there are so many different segments and different types of assets which are getting use cases developed on top of drones. And in 5 years' time or 10 years' time, it's really hard to predict these things. But we'll probably be looking at things like delivery, logistics, tree planting, mesh networking. People are talking about using drones for wall washing and doing some of the actual non-sensing tasks within a business as well. So if you sort of kind of agree to that premise that these applications will continue to increase and the ROI on the hardware will essentially decrease, then there's two things that come to mind. One is to try and understand what can drones do today for infrastructure assets. Essentially, what is the business case for them today? And then the other question to ask is, what do they enable in the future? And have we got an eye on the future as well, so that we don't get ourselves locked into some form of a local maximum where it's great today, but we haven't thought of a long-term strategy. So the three things that drones can enable today in infrastructure is to lower the cost of the asset inspection and maintenance. They allow for a lot more consistent and frequent inspections because essentially at the end of the spectrum, you have a robot doing the inspection, so you can be a lot more consistent, you can be a lot more precise. And as some of what Patrick demoed, they can enable a future of predictive maintenance where you can look at an asset over time and understand how it's changing. So whenever I say this to people, drones can really lower the infrastructure inspection cost, the first question I get is, great, by how much? And to that, my answer is always, it depends. It depends on a number of different things. I think the three things that it really depends on is, A, how efficient are the drone workflows? It's not okay to just use a drone and expect it's going to be ultimately cheaper. I think it's how you use that drone, how you use that data, how you build workflows in your organization that makes that cost value equation a lot easier to understand. Second question is, what is the competing technology? What is the, are you competing with satellite data? Are you competing with ground-based data? Or is it more of a fusion scenario where you're taking data from different sensors and fusing them together? And last but often overlooked aspect of this is, how efficient is the drone program itself? So you're using drones, you're using all this data, but is the drone program or the organization in itself using drones efficiently? Because that can be a complexity that's hard to manage. So let's start with those questions and start one by one. So let's start with, how efficient are the workflows? Well, to define that, we need to first define what the workflows typically involve. So typically in a drone inspection, the first workflow is to capture the data. And capturing the data is more than just taking some random images. I mean, that used to happen years ago, but nowadays it's very much, you need to capture data in a very precise way, and the data needs to have structure that you can then utilize to process that data into meaningful information. So organizing that is really important and key. The challenge there typically is, if you've got a lot of people in your organization collecting data, because humans are inherently very creative people, you want to make sure that there is minimal discrepancy in the way that that data is collected. So essentially over here, workflows, tooling, and training is key. The step two in that process is to essentially process that data into, it could be a 3D model, it could be a digital twin, it could be essentially annotated images. you want to be able to process that data into something that your business cares about. So essentially, some of these things look easy on the surface, but what the challenge is always, have you selected the right infrastructure for processing the data? Are you doing everything on desktop, or are you doing things on the cloud? What does your computer infrastructure look like in the organization? Has everyone got good internet speeds to be able to download and view this data? So again, it all boils down to doing the step 2, but doing it efficiently as opposed to sort of just doing it. And alongside with step 2, you also have annotation of the images. So similar to what Patrick already showcased, you can annotate images to understand where are the defects, what needs to be worked upon, how are different engineers communicating on an asset. But I think a lot of it is not just using the tools, but building workflows around the tools that builds that efficiency. And last step in this particular workflow that I'm showcasing, which is 3 steps of typically larger pipeline, is to share and evaluate the data. So are you thinking about how that data, where that data is going to live, how it's going to be accessed from different points of view, and whether or not people have the right infrastructure. So thinking about workflows, there's another topic that goes hand in hand with that. Even if you get all your workflows really efficient, one big question to ask is, how efficient is the drone program itself? So if you've got a company and you've got a drone program and you want to do drone inspections, the key question is, how are you managing all the different resources at your disposal? So you've got trained pilots in your organization, you've got different drones that you're managing, different software packages, you have insurance that you need to procure, cameras, and essentially the drone program itself becomes a resource allocation problem. How do you make sure that you're using all of these different resources optimally and you're keeping your workflow as efficient as possible? So let me share some scenarios that I've seen over the years in terms of how I've seen drone programs being run and architected. So normally the old world was, you have one use case with a drone, which is typically mapping or modeling some site or an asset. And you basically get the resources for that. So as an example, you want to do data capture, processing, and sharing as a workflow. You have a single asset. So let's take an example of pipeline inspections. You basically find the right combination of pilots, drones, software training for pipeline inspections, and then you work your way down. And that's kind of like a typical workflow. This works pretty good, pretty optimally. But the challenge is, as I mentioned before, more special purpose machines become general purpose machines. And over time, you actually want to use the drone for more than one use case to lower the cost and to improve ROI on that machine. And what happens is essentially you had one use case, but now you've got other use cases within the business. And each one of those is using its own resources. It's consuming its own workflows. So an example with this would be that you have like pipeline inspections being done, oil rigs being maintained, maybe methane monitoring being done. And each one of those now has a different type of drone, different type of training, different type of pilots, different type of infrastructure. And essentially, it becomes really hard to scale this way because even though you're really efficient in your workflows downwards, you're not very efficient across the board. So the new world, which I think is going to be a more efficient world, is if you're doing many different types of data capture, many different types of workflows, you would be able to do them with similar resources or resources that have an extremely high overlap. So, if going back to pipelines, oil rigs, and methane, you're not always going to be able to use everything the same way. So obviously you need to be able to sense methane. So you need a methane sensor as opposed to a camera for visual inspections. There will be discrepancies, but the aim is that in this grid, you try to make it look as uniform as possible so that you have consistency in your workflows and not every single use case is tackled separately or differently. And this is essentially where Hammer Missions comes in. And so essentially we built the software to think about what problems can we solve today within organizations, but also keeping an eye on the future for what problems people will face in the future because of the current architectures. So our first and foremost sort of goal with the software is to help the drone program efficiency. So help you use the same platform for multi-asset inspections, whether you're doing pipelines one day or you're doing oil rigs another day. You kind of consistency in how all of those things are captured and maintained. And that goes with other sensors as well, whether it's methane monitoring, magnetic surveying, and other use cases. Going back to the same idea that if you use one resource, it allows you to improve the ROI on that resource. So I've just got a couple of videos here from in-flight, essentially where you have, I think they're not playing at the moment. Let me see if I can play them just all at the same time. So essentially we've got, for example, a tower being captured over here using Hammer. We've got a magnetic surveying mission, essentially with a magnetometer being conducted. Different industry, not in energy, mostly used in mineral exploration, but essentially a different type of a sensor on the drone. And we've got a roof inspection being done, all using the same software platform. So all of the pilots have essentially been trained in the same software and can use the same technology at the same time. So that sort of efficiency also flows into multi-asset data processing. So you can process different types of data sets all from the same consistent platform, because you, again, want to build that drone program where you're getting all of those different modules to look as similar as possible. And you're trying to use the same software for many different tasks. And this will break, you will always find situations where the software can't do it. And then the question is, can you extend the same software to be able to add a new use case, or do you need to actually then go for something more specialized? But we are essentially building Hammer in a way that it can scale to any application in the future. So key takeaways from this presentation. So I think that specialized machines become general purpose machines over time. And as a business that is looking at drones, it's important to consider that when you think of your drone strategy. This is currently happening to commercial drones, and drones overall do lower the cost of asset inspection and maintenance. We know the ROI is there, the business case is there, but it's even better to look at how do we get our ROI even better by focusing on a multi-asset approach whilst building a drone program. And Hammer Missions is a software platform that we're creating to address this particular problem. And last but not the least, I'd like to leave with a thought, which is to always put the data and decisions, business decisions and business data first, and to not get driven by the technology. It's happened to us. It happens to a lot of companies that are very sort of technology driven, where you essentially put the cart before the horse, and you don't really realize that it's actually the data and the business case that brings value. So really important to sanity check every decision from that point of view. So that's pretty much it. Thanks so much for listening. I'll be happy to take any questions now. So I'm just going to switch back out of the sharing view.
Yes, I think we can open the Q&A session. So thank you so much, Varun, as well, for your presentation. Very interesting, very much tied in onto the back of what Patrick was saying. Maybe I can start off with one question, and then people hopefully will follow either with a hand or with a text. So one question for Patrick, so we'll go back to you. So what you show is a very clear business case, but as you mentioned, why are we not seeing the utilization of drones at every facility? What is stopping the industry from scaling up these operations?
Well, from my point of view, or from our point of view, is that you have usually what struggles to catch up is regulation. So to be able to deploy at scales at the moment, you would need a drone pilot at every facility, and to be able to fly safely, you need obviously a trained drone pilot, and usually people that act as pilots from the asset owner point of view, they are just doing it part-time. So there's no support because it's not really safe. And so the only other thing you can do is start being able to obtain permits to fly remotely. So you fly from one office and you inspect multiple assets, or automated solution, drone in a box, they fly, they do their inspection, and they come back. So that's where we're going, but that's what is really stopping a huge, massive scale adoption, I think.
So that makes me think about Varun coming into place, right? Varun, your system seems to have removed the differentiation on hardware and skills that you need for multi-asset, and you brought that into your system. So how would you rating working better a specialized inspection versus a general purpose drone with the aid of your system?
Yeah, it's a good question, and I think what we normally see is that typically like businesses think that we have a business case, so let's try and find the best drone for it, and they find a very specialized drone for it, but that specialized drone actually only provides like a 2x, maybe 3x improvement on a general purpose drone sometimes, and the cost of actually then learning that specialized drone and all the associated sort of infrastructure around it, whether it's the software it supports or what retraining you need for it, sometimes doesn't justify the extra value it brings by it being specialized. So I think it's hard to say whether you should always go specialized versus general purpose, but if the use case doesn't, if the specialized drone doesn't bring an order of magnitude more value, like a 10x improvement on a general purpose drone, then it's better to stick with the general purpose drone, because you then kind of know that everything else around it is supported the right way. So,
and maybe just I continue with you, Varun. What's inside the box that enables this exchange of sensors and asset to be inspected? Are you using any artificial intelligence that is supporting the understanding of the data behind?
yeah, so on the data processing side of things, at the moment, our data processing is very much on the visual side of it. So whether it's processing images from 2D to 3D, whether it's automatically annotating the images based on some essentially AI. So if you're looking for cracks, corrosion, or some form of defect, but we think that overall, things are moving into more than just visual. So, there's LiDAR in the game, there is thermal in the game. And so some form of sensor fusion will be really important in the future. We're currently focused on the visual side of it, but we think that for us to be able to support any kind of a use case, we'll probably have to go multi-sensor.
Yes, and you mentioned also predictive maintenance. So how do we ensure that we have the data correctly interpreted, analyzed, or processed first, and then analyzed to achieve a predictive type of behavior?
Yeah, so the predictive side of it is really interesting. So I think that's one where you need a lot of data at scale. Because you don't just need, here's a few images, find defects for me. It's more find how those patterns, recognize those patterns when, how quickly is this crack developing, and last time when things broke, how much sooner should we raise a flag? So I think it's interesting. And to me, one of the interesting questions is like, does this data already exist, or do we need to generate this data over the next 5 years before we can even think about predictive maintenance? I don't know if Patrick has more to add on the predictive maintenance side of it, because I'm sure like Cyberhawk's collecting a lot of data and probably in a good position to start thinking about some of these things.
Yeah, similar. It's every type of every time you have to want to use AI for detecting something, you need to redevelop a new algorithm, because it's different type of things you're looking for. So whether it's rust on a tower or rust on a platform or wind turbine. So that's the challenge. There's no holy grail.
So Patrick, maybe we can continue with you though. So where do you see the biggest return on investment for the inspection and missions with drones? Is it the multi-temporal collection of data? It's providing those insights?
So at the moment, I think at this stage still the biggest one is drastically reduce the amount of time you have people working in dangerous environments, in remote environments, being able to have richer data so that you're able to make better informed decision on other work. So it's the preparatory work is a scanning tool really, right? So what allows you is a screening tool, sorry. Is what allows you to do is to understand more in detail the specific work you need to do with other disciplines. So the biggest return on investment, you're drastically optimizing and reducing cost to manage a facility. And then of course there is the safety and environmental as well improvement, but usually they are, I guess, considered on the side. They're not necessarily the first priority. So yeah, there is a direct cost saving first, and then an improvement in safety and environment.
So to both of you, I'm just thinking, looking at the future, where do you see the biggest competitors? Do you see any potential disruptor? I mean, drones have been disrupting the acquisition of data through satellites or through planes, although each of them has its own use case and reason to be. But do you see anything that may disrupt the way we are collecting data, whether it's on the hardware, whether it's on the sensor side, or whether it's on the way we manage the data?
Who's going first? You, Varun?
Happy for you to go if you've got competitors in mind.
Yeah, I think that if you have someone like I think AI now is being deployed at scale, so we're gonna see the biggest improvements in other industries like transport. Uber, Google and Amazon, that they're gonna probably now start liking, trying to deploy AI to start flying drones automatically and detecting defects automatically. So I think, yeah, these are the biggest, I guess, threats.
Yes.
Yeah. I would also sort of, I think there is also the inherent threat of kind of like the drone hardware being available and being available in the right way for us to be able to continue collecting this data and being able to serve. I mean, if you think about what's happening in the world geopolitically right now, one of the threats is I think right now the demand supply for drones, the number of drones we need for the number of use cases out there, I think we're okay. But given what happened in other industries in terms of chips not being available and hardware infrastructure not being available, I wonder in the future whether we're going to have enough drones kind of available to supply the demand that there is, and there might be that some drone manufacturers potentially want to lock things down a bit more and want to control things a bit more, which might have some implications in the industry. So I think things being open and connected are quite important.
Yep. Absolutely. We have some questions from the floor. First one from Klaus, I guess is for Varun. What language do you program in and where do you train your pilot? Am I correct, Klaus? Is for, at least the first part of your question is for Varun.
I guess we can both answer if you want, Varun.
Okay, go ahead.
Yeah, sure. Yeah, I'm not sure why the programming languages is kind of important. I mean, we have a whole plethora of languages that we use for the platform, and they're all just like modern programming languages. But I wonder if there's like a kind of reason for that question. Then I can probably take that a bit more closely. Where do we train our pilots? So we don't have any pilots, so we don't do any data capture ourselves. We essentially, I'm beginning to think this question might be for
so maybe for Patrick.
But yeah, we only help organizations train their own pilots essentially. But I'll let Patrick continue.
Yeah. So pilots, we train the pilots here in our facility, in our headquarters in Edinburgh, Scotland, and but we then also have now a facility to train them in Denver, Colorado, in the US. And then language. So our software is built in mostly. I think it's Oh, is it Python? I actually don't. Yeah, I don't remember it's Python. I think it is. Yeah.
Would be a good choice.
Yeah. Second question from Callum. Hello, Varun. You mentioned methane detection in your slides. Do you think this type of data will present its own challenges versus traditional video images? And if so, what do you think these are?
Yeah, so I think with every data type, you definitely have their own challenges. Sometimes data types remove challenges that we have with images and video. So I can't speak about methane per se at the moment, but let's say we talk about sort of magnetic data, so magnetometer data, which is a different type of data that we see, and essentially that data is actually not 2D in the sense that it's just essentially just 1D sort of a data where you kind of just have a signal over time, and it has to be processed in a very different way. In fact, the processing for that data can be accomplished much faster, probably even on the fly in the field, because you don't have 2D images which are heavy. Instead of that, you just have this 1D, almost sort of like a sound signal, kind of like what is the value for every point in time. And there's location, but essentially for processing, that doesn't matter. So you can process it actually faster than you would be able to process visual data. So the key question is, when these different data formats show up, are they going to put pressure on the visual side of things and make the industry get that moving a lot faster? Because waiting hours for a highly accurate 3D model is something that we still take for granted. We take as okay. But to someone who's using methane or magnetic data, it's probably too much waiting time.
Yes, I think there's also another question for Patrick. What drones is your preferred drone and why? Do you have a preferred drone?
We had, and then it got discontinued by Intel. So we had to learn to replace it.
Oh, wow. Okay.
And so we are, we have 4 or 5 different type of drones, mostly Chinese manufacturer, DJIs, and then we still use the Falcon 8 from Intel. So yeah, it's not just one drone. It's depending on the tool you need. On the job you need to do, and the tool will change.
Absolutely, absolutely. Yes, there's just a compliment on the great session, but the question is more for us organizing this session, and so definitely I will get back to you on the question you have on this. Any other question from the floor? Actually, I would like to ask the floor, how many of you are using drones out there? I have been once. I'm not a great user. There's a skill issues on piloting.
Your backyard doesn't count, gents.
No. How many of you are involved with Ortega? Yes, Ortega, I can see you. Do you want to say anything about what you do?
My company is actually manufacturing drones to measure the environmental pollution and perform pollution abatement as well. So I work with drones doing that currently. But we do have drones to do other things like the pipeline inspection that Varun mentioned. We had drones, we manufacture drones to do that as well. That's it.
Excellent. Maybe I have a question then for you. There's the horror question I used to have when I worked in remote sensing, so promoting the processing of the data rather than the hardware. But when you would propose a facility manager to introduce a drone inspection program, the answer would be, why would I need to use a drone when I need to take a drone along the pipeline? So with a person, at that point, the cost for me is less if I hire a plane and I do a survey all at once with the same sensors, with the same potentially accuracy of the data being collected, and less risk for the pilots and the people going there. So has it changed anything today in the industry?
Yes, but my company, what we were proposing to them, to the companies, was to have the drones stationed on their pipelines and then transmit their data remotely to a location for them. So in that case, it's a continuous maintenance as opposed to you having a physical person go there to visualize the pipeline for you and see if there's any defects.
So unmanned systems and transmission of data are becoming basically the critical, let's say, enabler of this change. Yes, absolutely.
Yes. Yeah. Yes.
Excellent. Right. Is there any other question, or we can close this wonderful webinar here?
Mm-hmm.
Looks like everybody's really quiet. Anyway, I think we just reached my almost 4 p.m. In London. So I'd like to close this section here. If you do have any question, please reach out to the technical section, the SPE group or the LinkedIn group. You will find also the contacts for our guest today. Thank you very much, Patrick and Varun. It's been wonderful to see what you do again. I hope you enjoy also presenting and sharing with us. And we look forward to do it again soon. So thanks again and enjoy the rest of your day and the evening. Bye-bye.
Thank you, guys. Thank you, Christina.
Bye.
Bye.
Thanks, everyone. Cheers.
Bye.
Bye.
Bye-bye.
Bye.
Thank you. Bye-bye.